Chemistry Higher Paper 2024, question 9. Okay, so we've got a practical that's been done here comparing reactivity of different metals, and we've got different amounts of bubbles have been formed, and we've been given the order of reactivity. But we haven't been given the results for metal G. So we have to use the information in the table and the fact that G is the third most reactive of the metals to predict what the observations would be that we made. So we can see that it's going to be more reactive than F, where a few bubbles were formed and the metal looked unchanged after 3 minutes. But it's going to be less reactive than D, where the bubbles formed quickly and after 3 minutes all the metal had reacted. So here's where your marks are going to come in here. Bubbles formed slowly and some metal remains at the end. Okay, question here about dilute and strong acids. So what does the meaning of the term dilute and strong means in terms of acid? So dilute means it has a low concentration, 1 mark, of H plus ions. So that just means it's been mixed with lots of water, so it's got a low concentration. This is very different to a strong acid. So for this one, the acid is fully dissociated. And then second mark, forming H plus ions. So we're always referring to H plus because it's an acid. Strong acids are fully dissociated. Remember, weak acids are partially dissociated, which is not to be confused with dilute or high concentrations. Okay, next up then we've got an Avogadro question. We have to calculate the number of atoms that combine together to form 16.25 grams of lead ethanoate, which we've given the formula for here. So for this, you've got 2 steps that we need to do, and I'll just make a note of them here. So step 1, calculate the number of moles, and then step 2 is find out how many atoms there would be. Now we can see in the formula here, we can work out how many atoms there are that are going to be present. We'll work our way through all of this. So if we do a quick count, we can see that in the brackets we've got 1 carbon, I'm going to do a little bit of a tally, 3 hydrogens, another carbon, and 2 oxygens. So that gives us 7 atoms, but there's 2 of everything that's in the bracket, so we're timesing that by 2, so that gives us 14. And then we're adding on a lead, so we've got 15 atoms in our formula. Okay, so we're going to use that to calculate the number of atoms. So step 1 then, let's calculate the moles. We know that moles equals mass over Mr. So we have got a mass of 16.25 grams, and our relative formula mass, so we're going to have to work all of this out given this information here. So our MR is going to be 207 plus, we've got, let's get this right for us, let's do it in the brackets, so we'll do 2 times 12 plus 3 times 1 plus 2 times 16, and that's going to give us a total number for our relative formula mass of 325, so that's quite a complicated one. Okay, so 16.25 divided by 325 gives us an answer of 0.05 moles. That's our starting point. We know that each of these molecules has got 15 atoms in it, and we also know that 1 mole contains that number of particles. So I'm going to go to my next step, number of, and we'll do Pb CH3 COO2 equals 0.05 multiplied by Avogadro's number, which gives me 3.01 times 10 to the power of 22 of all of this thing here. And each one of those contains 15 atoms. So my atoms equals 3.01 times 10 to the 22 multiplied by 15, which gives me an answer of 515 times 10 to the power of 23. So that is quite an involved calculation. There's quite a lot going on there. You've got to calculate MR, you've got to calculate the number of atoms in the formula, you've got to calculate the number of moles. That's why it's a 4-mark calculation. And here we've got some more moles to do. So we've got iron displacing copper from copper nitrate, and we've got 2.24 grams of iron reacting with excess copper nitrate to form 3.81 grams of copper. We have to show which of these equations represents the reaction taking place. So it's all about our ratio in the equation. So you can see in equation 1, our ratio of iron to copper moles is 1 to 1, whereas in equation 2, our ratio of iron to copper is 2 to 3. And if we work out how many moles of iron we've got here and how many moles of copper we've got here, we can work out our ratio, and that will tell us which one of these equations it's going to be. So let's do our mole calculation. Remember that moles equals mass over Mr. So for iron, the moles of iron equals 2.24 divided by 56, which gives an answer of 0.04. And our moles of copper is 3.81 grams divided by 63.5, gives an answer of 0.06. Now remember, we said if it was equation 1, it'd be a 1-to-1 reaction. So we've already proved it's not equation 1. Should be a 2-to-3 reaction if it's equation 2, which is correct. This gives us a 2-to-3 ratio, so it must be equation 2. And that is question 9.